Dear friends, in the C programming problem series, I'm going to talk about problem number 4 now. Okay, so you can look into the screen. You have a very simple piece of code here. We have declared a character variable C, and then we are trying to do an assignment operation of 255 for that character variable, and then we are simply trying to display it. Okay. Now, one of the goal that all of you should have is you should do an analysis of the code and then try to deduce what should be the answer. Okay, especially in C language programming, what you see on the screen is obviously not what you will get in the output many a times. Okay, they look very simple, but when you run it, you will have very different answers. And the most important thing is when you dig more into it, when you really jump little more into it, you will have much more additional findings. Okay, and that is the crux of a core systems programming. Okay, so my request to you is at this point of time to also analyze yourself. You can pause the video if you would want, and then you can resume the video. Analyze, get your findings as part of analysis, and then finally run the code and match your results, right? So you are analyzing and matching your results, and then try to dig more into it. You can also join the Telegram group that I always keep referring, because this is easy for me to communicate with all of you, okay, in a central place. So let's look into this particular problem. Okay, in this problem series, what you see is I am trying to do an assignment operation of 255, right? So when you do an assignment operation of 255, you are trying to really break into the boundary of the character. Okay, so why? Because 255 is the highest possible value that you can store for 1 byte, right? Now, what is right and what is wrong for this, and why the computer is printing or not printing the values? So a lot of people, when they read this kind of code, they will say, the answer of this can be 255 itself, because it is as simple as that. But some of the students, they will say, no, it is not 255, this is an error. Why it is an error? Why? Because they say that 255 is not a character. Right? So you have a logic where you say it's an error. Because 255 is not a character, but in reality, when you talk about a character data type, it is 1 byte. It can store practically anything. Okay, anything where we can store in 1 byte. As many of you already know that a character is nothing but a symbolic representation for some of your keyboard visible sequences and invisible sequences, right? So it's like a symbolic representation, but we represent it, we store it internally in terms of a numerical value, popularly known as your ASCII code, right? So yeah, your assumption is fine here about your analysis is fine that it's an error, but will the computer display an error? Will it give a compilation error? That is what is important, right? So compilation error, is it giving, or it maybe it's giving a warning, or it's not giving any of those, right? So I think this kind of problems will really tease you a lot. It will try to stretch your brain and try to think more about it actually. Okay, and then some of you will say yes, it will print maybe some negative numbers, right? Somebody say it might print -1, right? So you will have different answers for this. Why it is -1? Because we will discuss this in the detail in the lab now. Okay, so let's jump into the lab. You will have different interpretation and answers. So as I said, C is always things behind the scene. So let's jump into the lab, and then we will try to work and give much more detail. I am going to show you some additional details about how things work actually. Okay, something about certain rules in the C programming language. It's a classical exercise to understand one very inherent rule about printf, stack operations, rules in the programming language. Okay, so let's go into the lab. So we are program number 4 now. So this is the code, as all of you know. Let me simply go ahead and compile this code, right? So we'll compile it and we will run it. And as expected by some of you and unexpected by some of you, the answer for this is -1. It is not an error. Compiler did not give any error, right? Compiler did not give any error. Runtime did not print 255. It did not print 255. it printed a negative number -1, right? So now we have to understand why it is -1 in much more detailed way. Okay, so let me open the code and write my interpretation, analysis, whatever we call it, as a commented lines here. Okay, so let's do our analysis portion for this particular piece of code. Okay, so when you look into C equals to 255, right? So C equals to 255. So you know that C is a character. Okay, now remember that when you talk about character data type, we have to understand that what's the memory behind it, because C language, I have made a lot of videos, as you would have seen. I emphasize a lot on the memory. Okay, because anything you do on the C, it has an impact on the memory, and which will backfire if you don't understand. Okay, so when you talk about a character data type is how many bytes? It is just a single byte of operation or single byte of memory storage. Single byte translates into 8 bits, as you can see, right? It's an 8 bits basically, right? And what is the maximum possible value for an 8 bit? What is the minimum possible for an 8 bit? So when think about minimum, 1, 2, 3, 4, 5, 6, 7, 8. So that's the min value, right? For an 8 bit entity, right? So what's the max value is what we can think. So when you talk about max, it is 1, 1, 1, 1, 1, 1, 1, 1, right? As simple as that. Now things becomes much more interesting here. Okay, so some of you might have thought that when I printed it, it should have printed, it's a 1 byte we are storing, so it should have printed 255. Why it printed -1, right? And that's a interesting question, isn't it? So when you look into the data type for C, so we have a variable called C. What was the data type for C? Data type was a character. What is the nature of that data type? Was it signed or unsigned? What was that? By default, the implementations of the C languages by most of these compilers, what they do is they will treat them as a signed integer, signed character, signed data type. If you don't specify the sign, it's always a signed character. When you say signed character, some of you already knows the 2's complement notation, or you understand that this bit is also known as this location. This guy is also known as the most significant bit. So when you think about this, least significant bit, and this is most significant bit, and most significant bit is used to store a sign, right? Okay, I think that's where the hint and the answer lies. So in this case, what you see is bit position 7. Bit position 7 means we start from like this. Okay, so 0th, 1st, 2nd, 3rd, 4th, 5, 6, 7. The 7th position is nothing but a sign representation. It's a position not for a data, it's a position for a sign. Okay, so 7th bit position for the char is your MSB, which is a representation for the sign, right? So this is the representation for the sign for you. So having said that, suppose this is 1 as a sign, right? Then you are left out with this. That's pretty much it. And the answer is 1 followed by so many 1s in the internal memory. Remember, this is getting stored in the internal memory, right? Okay, so 1 followed by 7 1s, what it could be, right? And that generally is -1. You might think how it is -1, so you have to understand how you can store -1 in 2's complement notation in programming, right? Basically, if you understand how to do -1 in 2's complement notation, you will see that this is the number, right? I have done a lot of videos about data types. I think you should watch it, because I have given lots and lots of examples with explanation the way I'm explaining right now. I have explained in quite more detail about the signed, unsigned, and 2's complement notation, right? So please try to watch bunch of videos on data types that I have in my advanced C programming video tutorials in the YouTube. Okay, so -1 basically is represented with all ones. That's the short answer. Long answer, you can watch some of the videos that I have. Okay, so now that's the reason that when you display it, it's basically a -1 here. things become much more interesting if you are still watching this video. Okay, I'll show you much more interest about this data. Okay, so let's look into this particular data, and then we will try to display it in slightly different format. Okay, so I am going to display in a hexadecimal notation, as all of you know. So this is the hexadecimal representation for 255, right? Okay, so now since you have understood why it is -1, we have to just make sure that, okay, what will the value for this, right? What we'll also do, for the sake of clarity, before I jump into this interesting printf, okay, let's see, you do have a character as an unsigned character. I repeat, unsigned character. Okay, so unsigned character means all the 8 bits represent a value, so they are not at all signed. And when you write 255, yes, it will be 255 only, isn't it? So how do we do that? We will say c equal to this, we'll keep it as it is, we'll introduce one more character which is known as unsigned character. We'll display them, we'll print them, right? We'll say unsigned char, we call it as UC. UC is an unsigned character. Okay, we'll do the ditto same printf here. We'll say C and we say UC. Okay, so we'll say and UC, and then we will write UC here. Okay, let's run this code first and then try to understand what the answer is actually. Okay, so we are running it, and then you got to 255 because there was no sign bit. Everything is a value, right? So as you know that everything is a value, you pretty much know, yes, it has to be a 255. Okay, all right, so I think this was an interesting thing, and thanks for this one. Let's come back into a very interesting problem. So I will remove this UC, and our code is now simply reducing to basically these 2 lines. Okay, any guesswork by some of you? You can pause the video. Any guesswork? What will be the value? The value, will it be in hexadecimal notation? Will it be FF or something else, right? Okay, so let me quickly run this code, and you will see that it is not FF. FF generally means 255. Okay, so it is not FF, it is FF 8 times F, which is a 4-byte entity actually at this point of time. Okay, so this is $1 million question now, why we are seeing 4FF, right? Basically, so if you see the code that I have written here, okay, you will see that I have just converted it into a hexadecimal representation, and it shows as FF, right? So there are certain rules which are inherent in the C programming language in terms of how things work in the stack, especially for some of the data types. Okay, so we have rules which is responsible for pushing a larger value than what we have put into the arguments of a printf. So printf has 2 arguments right here. Okay, so I'll be making a slightly different video because the focus of this video was different, right? But since some of you are very keen and serious, people who are watching this video right till this point actually, okay, so this was like a bonus for you to understand a problem first, right? So it's not showing FF, it's showing FF so many times, right? So we will solve that in some another video. Thank you very much for watching this, and I will see you in another problem sometime. Okay, bye for now.